I've been looking for some kits to build on the internet, and I ran across this group here, NightFire Electronics. I don't believe I've ever dealt with them, and their kits are sort of simplistic, but I found one I think I might be able to use. I ordered 2 of these kits. I also ordered some crystals. These were 99 cents a piece. I was going to pay shipping anyway on a kit, so I figured. Each kit came with documentation, 2 schematics, just 2 schematics, and an invoice. So I got 2 kits and 3 crystals 2 times over. The kit I ordered was this Colpitts Crystal oscillator. Now I copied this from their website. This link leads to a schematic, which I printed, but they also included with the kit. There was a link down here that said other kit information or something. For first-time kit builders, this link, which is invisible because I didn't copy it, is excellent. It's about 20 pages maybe, colored photographs of all different kinds of components, surface mount and through hole, and not just related to this kit, but just in general. I wish I had printed the link out. It is a very interesting link, especially for new kit builders. And that's what NightFire seems to be cultivating. The reason I chose NightFire's Colpitts oscillator was that it's a 3 transistor rig. The final stage is a emitter follower. We used to call them cathode followers. It has no gain, but it's a very good isolation stage. I can do anything here and it won't affect the oscillator. Now, NightFire sells these under the name vakits.com. I believe NightFire and VA are one and the same. They do offer this Colpitts oscillator kit with surface mount devices. And the kit cost $10.99. So over $25 is free shipping. Keep that in mind. 3 transistors. So we've got 10 resistors, 7 capacitors, 3 transistors, and 2 screw terminal blocks, and the PCB. Now, this is a very nice looking printed circuit board. Values of the components are not on the board, so you have to work with the schematic. There's numbers. I thought the photograph showed a BNC connector output. What does it say? See, we show an RCA connector. So they don't mention the output connector in this document. And they don't indicate anything on the schematic. So I fitted the circuit board with these temporary blocks. This particular set is made by QRP-Me. So let's look at what we have here. I'm going to use the VOM to verify all of the resistance of these. So I just picked a resistor at random. Looks like a 5.6 something. Measures 554, but the color code says 560. And there are two of them at least I see right off the bat, R10 and R8. And R7. However, there's a 5.6K, which would be the same two colors, but this one will have a red band, while these have a brown band. So I can pick any one. Let's go with R10. And these don't need to be bent. They don't even want to be bent tight against the body. Most of the Chinese kits are tight against the body. This is probably a little too much, but we'll see what happens. Now you'll see why I use these blocks. So here's the resistor sticking through the holes. If I turn it over, the resistor will fall out. So I just bend the leads. Sometimes I just use my fingers. Not flat against the board, but enough that the resistor won't fall out. And then these legs keep the leads from bumping into the table. This is another 560. The writing on the board reads from left to right, English style. The color code on the device, in this case is a resistor, a green, blue, brown reads right to left, unless I do this to it. So I try to keep the color code lined up with the direction of text. And since we only have 10 resistors, I'm going to go ahead and put all 10 resistors in before I solder them. That way, when I get to the last resistor, it had better match the value. Well, we're down to one resistor left, R9. R9, according to the schematic, is a 100 ohm resistor. The only resistor I have left over is a 10 ohm resistor. Now, just out of curiosity, I'm going to check the other kit. Because if you had just purchased one of these kits and you didn't have a stock of resistors, I mean, what are you going to do? Radio Shack's not available. Alright, kit number 2 also has a 10 ohm resistor. Now I have a bit of a dilemma. These resistors, R2 and R4, are decoupling resistors. They're a resistor from a power source and then a capacitor ground, both cases. Both 0.1 microfarad. Both 100. That isolates these two portions of the device from each other. At least it prevents back coupling through the power supply. So it makes sense that these would be identical. Now we go down here. R9 is some sort of an RF bypass. So I don't know how this resistor was sized by the designer. So I'm going to go ahead and install the 10 ohm resistor here. I have plenty of 100 ohm resistors laying around, but let's see what happens if I install a 10 ohm resistor. I've got all the resistors installed and the legs are splayed out on the bottom. The other thing I like this temporary mounting system for is because now it gives it some weight, and it also stands the circuit board off this far from the deck, so the resistors at least are not rubbing up against the deck. So now it's just a matter of soldering. You want to try to make sure you don't solder any holes that don't have wires sticking through. And then we trim the wires off. Now I'm wearing glasses. I recommend you wear some eye protection. And you hold on to the wires so they don't go flying. Then we'll do the same thing for the capacitors. Now here you've got to be a little more familiar with the nomenclature. These capacitors are marked 104. Well, there is no 104 on the capacitors. It's 0.01, 0.1, 0.1. 330 puff, you know. So you need to become familiar with the way capacitors are marked. I have two capacitors marked 104, one capacitor marked 331, I have another capacitor marked 18, and I have three capacitors marked 103. Well, the 18 and the 331 are these. The 18, which is 1-8 with no 0, and 331, which is 3-3 with 1 0. That's how these are marked. So the same logic, and a 104 would be 1 0 0 0 0 0. So this capacitor is marked 18. This capacitor is marked 301. This is a 104. As is this one. And then this one is a 103. A 103. And a 103. So now that we've found out which capacitors are which, we can go ahead and just stick them in the holes. Start with C3, that's the 18 picofarad. Now I'm going to position it so I can read the value from this end of the board. and then spread the leads so it doesn't fall out. This is a 330 picofarad, which is C2. Do the same thing, just push it down, bend the leads out. And so on. All of the capacitors have been installed. C1 is not included in the kit. So don't fret over the fact that C1 doesn't appear to be there, because it isn't. C1 in fact is an option. Do the same thing, turn it over, solder, trim. At this point, we're nearing the home stretch. There are 3 transistors that are all identical. They're all 2N3904s. The nomenclature for a transistor is Q. So we have Q1, Q2, and Q3. And the silk screen shows it rounded and flat. Rounded and flat. Well, these things are actually rounded, looking down on them, with a flat face. You could tear these out of this package, but I'm just going to trim the leads. That way I don't have any glue on the leads. It's just a matter of lining up the flat side with the silk screen and pop them in. I just bend 2 of the 3 legs for the same reason, keep them from falling out. So now we only have 2 things left. There's a 3-terminal screw block that's used to connect the crystals to the oscillator. And there's a 2-screw terminal block that is the power. Make sure that the blank side is facing inward and this lead side is out. I prefer to hold these with these reverse acting tweezers. Well, first of all, we can take off our QRP-Me blocks. Now just solder one of these terminals. And then turn it over and make sure it's flush, in both directions. Then complete the soldering. I'll do the same for the crystal connection. Put it in there. Turn it over. Now the only thing left in the kit are these 2 sample crystals. Now what we don't have is an output connection. So we do have this crystal connection and this power connection. They're different colors, but there they are. we do not have an output connector in either of these outputs. But I do have some 2-terminal output devices, which a first-time kit builder may not have. So I'm going to go ahead and put an output connection on this. Bear in mind that no output provisions are provided, at least with my kit. I've got the board hooked to a 9-volt power supply, the output to an oscilloscope. I'm going to plug in this crystal, which is marked 8.862. I've got it hooked to, like I said, an oscilloscope. Here is the output trace, 8.9 as opposed to 8.8. And the other crystal that came with the kit is marked, it has a 15 on it, but it's followed by a K. So I don't know what actually the frequency of this crystal is intended to be. The oscilloscope again, 15.9 megahertz, but I don't know what the crystal was intended to be. Here's a crystal that's marked 20 megahertz, 50 picofarads. So here's where being able to adjust C1 would be important. So the 20 megahertz crystal is oscillating at 20.094. Perhaps we could adjust that frequency a little bit by pulling it with a capacitor at C1. So there's a little NightFire kit that's $11. You couldn't buy the components for $11. So I hope you enjoyed this video. Thank you.